All right, welcome back everyone, and we're going to continue some more WebVR again, and this time we're going to do head tracking. We did a little bit of head tracking, but we're like seeing through the headset in the last video while we're tracking our head. This time we're going to be in more of a spectator view. We get to see the headset move around in the on the stage of our room scale. So I did some small changes while I was experimenting, and so we're going to just do those small changes now because they kind of make sense. One big change is that I changed the name of the variable from fStageViewMatrix to fStageViewMatrix in INV, just so I know that that's been inverted. So I know that matrix is an inverted matrix. So in every single place, you kind of just update. You got update here, here, here. Let's see if we scroll down a little bit more. Inside our get I matrix, we updated it there too, and get pose matrix we updated here. I'm going to show you some things I was experimenting with that kind of shows that certain things don't work. It has to work this way. Because the previous lesson, I thought I can probably use the sit to standing transform that's uninverted, so I can kind of get away with not using all these inverts, but then kind of realized it doesn't work that way. You know, I'm not a mathematician, so I guess there's a very good reason why it's built the way it is. But we'll go through a little bit at the end what it looks like when I try to, see if I can optimize or fix it a little bit. So we do that here, and that's really all the small changes I had to do in this file. So now we go to the HTML page, and we're going to turn on our camera. Because now we're not going to use the headset to render. We're going to render straight to the screen. So we've got the camera back on. We're still keeping all our VR stuff because we need to get the update of where the headset is at any given moment because we are tracking the helmet. Everything I believe stays the same. We're going to use the cube that we had laying around to actually track, to be, kind of simulate where our head actually is on our stage. So that's that in the unready page, unready function. Okay, so on the unrender function, there's some changes. We're going to do update our camera because, again, like I said, we're using our normal camera. I think I took something out of here. I can't remember what it was. I need to look back on the GitHub. But what we need now is this. It's kind of a little hacky, but it works. What I'm doing here is I'm getting the position. It's all the position of the helmet from that function that we had from the previous lesson, and I'm dumping the 16 long float array. And I'm dumping it inside the raw, inside our transform. Because this is our matrix 4 class, and that's kind of like the raw value, the actual array we have access to. So I'm kind of just dumping it in there, because what I was trying to do before, I was trying to get translation out of the matrix. And then I got, then I tried, get orientation, which gives us a quintorian. But the way we have the entire thing put together, we don't use quintorians. We use Euler. We use regular 360-degree type of thing. Euler, I think it's pronounced. Again, I still can't pronounce these things since the last video. And so I was having problems converting quintorians to Euler. Though, like what I was trying to do is try to take... basically try to rebuild our model view inside our Gmodel class by, kind of just resetting it, adding the position, adding the rotation, and then doing an update. And I realized that was kind of too much work for what we want. So what I decided, which is probably the quickest way, is like the only thing that we're missing is scale. So this has our rotation already built in, and it has our position, our translation built in. The only thing we need to do is add scale, and scale is always added at the end. So after you do the other two transformations, you add scale. So I was like, you know what? Use the matrix that we have already and just append scale to it. So that's what we're doing. So I'm kind of just copying it over, putting it in a raw, and then telling our actual matrix function to take our scale that exists in our transform and just apply it to the matrix. So I'm kind of doing everything at the raw level and not using transform to do the work. I'm kind of doing it at the matrix object level. So like I said, it's a little hacky. Maybe down the line I'll build like a transform that allows us to kind of just throw in an override matrix. So this way we can say transform set raw override, and then we can kind of just take this and just plop it right in there. But it won't change the position or anything. So that's kind of like a big problem, is actually getting the rotation out of the matrix. Seems to be like a very pain in the ass thing to do. So this is something we don't need to do very often, but you know, for optimization, to make it easier to get it done really quickly, that's what I had to do. So that's a long-winded explanation why, but like I said, it's just the quickest way to do it. We're going to render our grid floor with our camera. You're going to be using, you know, render VR, and we have our shader, and like I said, we're just using all our regular render stuff. Now the only big difference I changed is I modified the shader since the previous lesson. So I'm putting an out variable called color, and then based on the face of the cube, I'm drawing a different color. So if it's the front face, I'm drawing red. If it's the back face, I'm drawing green. Any other face, I'm drawing gray. That's all I'm doing. And then our fragment shader, a lot of things were commented out. We just take the out color. Actually, sorry, right here, the in color from the vertex shader. We're bringing it in, and then we're just applying it. So those are the only real big changes. Like I said, it's this with that, this one, and this one. Those are the big changes here. So once we apply it, we have all the information, and now we can go to the browser, and when we refresh, there is my room scale thing. This is what my place space is set up for my Vive. So now that I get my Vive, you can see now we're tracking the head, and the cube that we have is showing basically where this thing is in my room. As you can see, the green is the front, and now this is pointing right at you, but what you see is the back, which is red. So the red is the back, which is aiming toward my face. So I'm tracking this thing pretty perfectly, as you can see. And you know, I go across the room, and this is like the end, because this is where my desk is. So what I'm going to do now, I'm just going to get up and walk around my play space, and let this thing kind of show you that I'm actually walking around this room. So this is kind of a good example of room scale and head tracking, all done in kind of in a spectator kind of mode. So I'll be right back. All right, let's get this back over here. So that's it. That's a quickie. That's pretty cool. Very simple. Pretty much a quick. Oh, the mic was away from my face. That was a quickie. So there you go. The room scale, head tracking, fun joy. So let's go back to the code. Now I'm going to show you some of the experiments I was doing that pretty much proved futile. If you guys are like mathematicians, probably you can help me out here. Let's see. So if I go back here, So what I thought that I could do was that since I was taking the sitting to standing transform and inverting it and saving the invert so I can use it for our left and right eye rendering, because we need it. We need it to be inverted because, you know, we want everything to move away from us. And we want to apply it to our left and right eye view matrix, which is also kind of an inverted value. So it's going to invert with invert, and there's a minus sign in there. So since it's inverted, it's like, you know what? What if I can just, you know, since I'm like building our transform, inverting it, then applying our inverted matrix to it, and then inverting it back, I thought, you know what, that's too many inverts. Maybe I don't need to do this. I thought I only was doing this, or the sample I was kind of using to learn was doing too many inversions. I don't know why. It's like, this makes no sense. So I thought, you know, why not just get rid of all these inverts and just multiply the transform by the uninverted version of the thing that comes directly from the headset. So if I click that and go back here, there's the headset. But as I'm moving across, it's actually kind of doing some kind of weird rotation. Like if I rotate the headset, it's like it's not rotating in place. So yeah, it's like it's kind of weird how it's working. So yeah, so it doesn't work that way. So you definitely need to do all those inverts, and you kind of need that invert version. So in previous video, I said that probably don't need it, but it definitely do. You definitely need to do it this way. It's, you know, it seems the only way I can get it to work is by doing it this way. So yeah. And I tried different things. I was like, you know, I don't know. I tried different combinations of this. Like, what happens if I don't invert it at the end, and refresh again. Now the camera's under, but now it functions incorrectly again. But now it's under the stage. So I know if it's inverted, that means it's the height is going in the opposite direction. So that makes sense why. Like if I bring it down, it gets close to the floor. But when I start to bring it up, it actually goes further down. So you definitely need that last invert in the process to complete it. So I try to go online and try to, because I don't know matrix math that well. I'm still kind of new to it, so I understand the basics of it. But in doing the inverse, I don't know why you need to do the inverse sometimes. Other than the fact is like kind of just the opposite. So I found a good video at Khan Academy that was explaining inverse matrices, and it's basically kind of like you have A, and the inverse of A is 1 over A. So it's kind of like this. It's kind of like a division operation. So you're basically turning like a number into a division type of thing. So, you know, turning 5, the inverse of 5 is really 0.5 in general, kind of in general, not really, but I know I got the math wrong, but I'm trying to just prove kind of a point. So, so yeah. So that like 2, I think the inverse of 2 is really 0.5 because it's kind of like divide by 2 is the same thing as multiplying by 0.5. That's kind of like, well, actually they're the same value, so they're not really an inverse. So, and the inverse is like the opposite. So the video showed like more of kind of a complicated algorithm, not very complicated, but an algorithm on how to convert a matrix into an inverse. And the way they explain it is kind of like a division. So yeah, since I'm not a matrix mathematician at all, like I understand algebra, I understand geometry, I get an understanding of trig. I don't know calculus at all or barely. and anything beyond that is a little bit above my pay grade. Even though I am studying, I'm trying to understand more of this math so I can build the game engine as much as I can with the actual knowledge of my own knowledge. But yeah, yeah, I just wanted to prove that you need to do all these inverts. Now, if you can prove to me that there's a different way without it, that'd be awesome, because I would love to streamline all this. Because to me, this seems so cumbersome. There should be an easier way to do this without all these inversions and multiplications. It'd be nice if you can just, some way just apply the uninverted version to our model view transformation and just apply scale at the very end. But we just can't. So this is the only way to get it to work right. So you need that, and then we just apply that scale, because we need that scale because the cube is huge in space. Where are we? Unrender. So yeah, I'll just show you what the cube looks like if I don't have it scaled down. Yeah, it's massive. Scale-wise, look, because you gotta think everything is in meters. So our cube is built 1 by 1 by 1. So this is like 1 meter big, and my space is only like 1.6 meters across and 2 meters the long way. So yeah, so that's why I need the scale in there, just to make it look right, like to scale basically when we're So yeah, give or take, that is somewhat the size of my headset compared to the room. So yeah, there you go. That's it. That's it. That's head tracking. It's not really that hard. It's very, very easy, kind of just to have a cube follow along with the rotation and translation of it. So the only thing left to do in WebGL is really the Vive controllers. So that's the only last step for me to do, and that's the game controller object. I was thinking, since I'm doing the game controller object, once I get Vive controllers working, I can track them within the room the same way with the helmet. Walk around the room and have maybe 2 more little cubes follow along with me, and maybe pressing the trigger will change the color of the cubes, or I want to maybe shoot a cube away. I don't know. I'll see what I can do. We don't have much of a physics engine, so I have to code a lot of the velocity movement myself. Definitely need to get a graphics engine at some point so we can do some really fun animations, and we need a scene graph. We need that. So there's a lot of things we need to start building this game engine. But we have the basics of the rendering and everything down. So I think I'm doing pretty good. Not bad in 2 months or 3 months worth of work, I guess, working at night. So yeah, I was thinking after I was done with the Vive controls, and since I'm playing with the game object, I'll research on how to get maybe the Xbox controller, or just any game controller in general, like a gamepad. So after Vives, I'll see if I can do maybe the Xbox controller. So this way, maybe I'll build like an Xbox controller object, a camera control, like an Xbox camera controller. So you can use the joysticks to kind of rotate, zoom in and zoom out, move around a little bit. So that might be fun to do after the Vive stuff. So yeah, so hope you're having fun. Hope you're enjoying it. Hope this is great. It'd be awesome if I could just have that final velocity. When I lift up, take the velocity that I'm current at and just let it keep going into a slow motion. That'd be a freaking awesome effect. I have an idea how to go about doing it. It's like, you measure the last 2 points of movement, that determines the velocity, and then since it's done, you just then slow down the velocity based on some kind of resistance value, like whatever the velocity is of the rotation, the change of rotation. I guess like you can experiment, like rotate, multiply by like 0.8 or something, so it slowly stops rotating around the y-axis. That'd be awesome. I think that would be awesome. Maybe I'll tinker with that at some point for fun. Or if you know what, I would love to see you guys do it. Since I explained to you like how I'll go about doing it, I want to see you guys do it. Can you make that? That'd be awesome. I want to see you guys. That'd be a nice challenge. You know, all you have to do is keep track of at least the last 2 positions the mouse is. So if I'm going across the screen and want to do a mouse up, get the position of the mouse up and maybe the previous position of the mouse up, and that's kind of like your velocity, the change of the change between point A to point B, and that whatever that change is on the X, Y, and Z axis rotation, just take that change and apply that change until the change becomes 0. So you you multiply it by 0.8 or something like this, or 0.5, and you keep halving it. I probably would do like 0.9 or 0.8 instead of 0.5, but this way you kind of keep that rotation going at the same momentum, and it'll just slow down. So yeah. This needs it. This camera controller really needs it. It would just add a little nice polish to this camera controller, since now it's working really well. So yeah, this short lesson I think probably came very long. I don't even know how long I've been recording this. So all right, I'm gonna leave you guys alone. Go code that change for me. Let's do it. You code it. If I'll fix it up if it needs any fixing up, and we'll apply it to the project. And I'll credit the person who did the work. All right, that'd be awesome. That'd be awesome. Come on, help me out here. All right, like, subscribe, and I don't know. That's it. See ya.